Oh yeah, so what is hot about a minimum, and I say minimum, of well-distributed body fat? Now compare a little bit humans versus monkeys. Just in a nutshell, the lovely lady on my right, on your left, she's offering to produce brainy babies for any male mate who wants to take her challenge. The poor monkey on the right here, she can't really afford to make that offer. But let's go a little deeper into what we're really talking about when we talk about body fat in primates. Or in all mammals, for example. Fat in all wild mammals. The main function is again a source of energy for life and reproduction. The total amount of fat in most wild mammals is 2% or even less, including monkeys. The wild humans that come closest to wild monkeys is human hunter-gatherers, most of which are no longer in existence, but the few studies that have been made, about 5% body fat in human hunter-gatherer society. In other words, our ancestors were not fat. They were lean, and the fat that they did have was well distributed. In modern humans, we have about 15% body fat in humans. Sex difference, males have half the fat than adult females do. Unfortunately, we also have an epidemic of obesity that started in the West and is now spreading to the East. We just eat too much, we have too much food, and so forth. But my main concentration here is looking at fat in wild mammals. If the distribution of body fat, of adipose tissue, is the same in all mammals, including humans. There are 12 places in the body where fat is deposited. And in monkeys at least, the distribution of the fat, it's all there, but how much of it is distributed depends on the species and its lifestyle. In monkeys at least, the fat is distributed symmetrically about a center of gravity. And when fat does accumulate, it does so asymmetrically. If a monkey eats a lot and gets fatter, okay, what I'm showing here is the amount, the percent of body fat, of total fat, that is found inside the abdomen, inside the abdomen over here, between the muscles, hardly anything, and under the skin or subcutaneously. And in a monkey where body fat is about 2% of body weight, body mass, most of the fat is found inside the guts, around the mesentery, inside the body cavity. A little bit between the muscles, and then the rest under the skin. What happens when monkeys get fatter is that there is a change in the distribution. The intra-abdominal fat spills over and under the skin. So the fatter you get a bigger tummy, yes, but most of that fat then spills over and accumulates under the skin. Here, for example, we have a monkey that is pretty fat, about 40%, and you notice he's got a big paunch there. That's because most of that fat that he's accumulated is now, gives him a pot belly. Now you look at this specimen and you realize, well, this guy's not very adapted for climbing trees. He's all right for sitting on the ground eating garbage, but he's not going to be very agile up in the trees. And that's the main point. There are arboreal constraints on monkeys that live in trees. It's not just fat, it's also the total anatomy. Macaques are typical, what we call above the branch quadrupeds. And they get their food from the terminal branches of trees. Most trees in the forest, they spread their branches and they have their fruit and the flowers at the very tips of the branches. And that's where monkeys need to go to find their food. So there's a constraint on body size for animals that have this sort of lifestyle. You can't have a big orangutan sitting at the end of the branch. It'll crack or he'll fall off. In fact, that's one of the constraints for orangutans. Orangutans are so big, they cannot access food on the terminal branches of these trees. They have to rely on big fruit like jackfruit, for example, that grows near the trunk. Anyway, the point is about these arboreal monkeys, there's a all monkeys species, whether it's macaques or those living in Africa or even South America, there's a constraint. There's just so many ways that you can put your bones and muscles together and still be agile in the trees. And that has been recognized for some time. What's not been recognized, that fat comes under the same sort of constraints. This is just another example of a langur feeding on terminal branches. What I'm trying to say here is that if you're going to make your living in the trees, there is a constraint on the amount of fat that you can carry around, and there's also a constraint on how it's distributed. A fat monkey, for example, would have lots of fat in the axillae. Well, that hinders locomotion. You can't have a big blob of fat under your axillae or in between your thighs and still be agile and in the trees. So monkeys tend to have, on average, about 2% body fat, and it's distributed in such a way that it doesn't interfere with the locomotion. And if they do get a little bit fatter, then it's concentrated on their paunch, on their belly, where it lowers the center of gravity and makes them more stable for arboreal locomotion. But there's a limit to this. You can't, be a huge fat monkey and still expect to be being well adapted for locomoting and feeding in the trees. So these arboreal constraints in body fat on arboreal monkeys, they extend to the infant. Infants have, when they're born, they have less than 1% body fat. They're really skinny little things. Remember I told you that story about the ugly monkey and the bus driver? Well, this is probably one of those things. But all baby monkeys are like this. They have less than 1% body fat. And that is because mothers just cannot afford to carry all that fat around in the womb when the infant is still developing, or after it's born. She still has to lug this thing around. But after it's born, it's a little bit easier because then it can sit by itself, and eventually she feeds it, and they put on a little bit fat as they grow older. But it's a characteristic of primates that live in trees that they have these really skinny, runty little babies. Skinny and runty, but they're really well, of course, developed in clinging onto the fur. They have other properties that make them well adapted to the trees, but fat is not one of them. All right, just a summary of the anatomical constraints for living in the trees and moving in the trees. So they have low fatness, 2%, and there's no sex difference. The males and females, there's no difference at all in the distribution and amount of fat. Females aren't, like in humans, are not more fat than males in monkeys. And fat is anatomically distributed to maintain a balance of weight to the center of gravities. And fat does accumulate centrally and ventrally so that the center of gravity is maintained. And importantly also, the fetus and newborns have no fat. Basically, I'm repeating. All right, what about humans now? Humans, we have a totally different story. The infants of monkeys, less than 1% body fat. Human babies are fat. They are the fattest babies in the whole mammalian world, fatter than seal babies even. 11 to 15% of fat at birth. And why do we have that fat? Because that fat is necessary for the proper development of the human brain. The human brain consumes so much energy and such metabolic energy that it needs to have a source for that energy, and that comes from the baby fat. And that baby fat comes from the mother's milk and from her fat. Mothers nursing, they burn fat off their thigh, not off their breasts, by the way. They burn the fat off their thighs to support the fatness of their neonates. As an aside, I get their fat mothers can't be arboreal, but never mind, we'll get to that. Fatness in humans. Let's just look at this for a minute. What is it all about? Boys and girls before puberty, they have the same amount and distribution of fat. There aren't any gender differences. Sons and daughters, same amount of fat and distribution. Once puberty hits in, once those hormones kick in, then the fat deposit in young girls increases. Women between 16 and 18 years old, for example, they have about 26 to 28% body fat, whereas in men, it's half that, about 14%. Men tend to put on muscle, not fat. And that's the amount. What about the concentration? In young women of reproductive age, the fat concentrations are found on the breasts, the buttocks, and the thighs. To give those females that typical attractive shape, that sexy shape that all we men we really admire. Post-menopause, the things reverse again. Women after menopause, they lose that shape, they lose the fat. And by the time they're 65 or 70 years old, they have the same amount, the same distribution of fat almost as their male peers. So this fatness, this concentration, and this distribution really coincides with the reproductive phase in women. Now there are two things that are important about fat here. The amount of fat is critical for rearing fat babies that eventually will be with big brains and be intelligent humans. But the distribution is critical, not so much for the baby, but certainly for attracting male partners. Now, why should human females have to worry about getting a male partner? You know, I mean, sex, you know, like monkeys, it's pretty common. Why would you want to hook a male and make him hang around with you? Why would you want to have that person, that body shape that pretends that you're sexy all the time? Well, monkeys have young monkeys have a long period of development. And it's really tough for a female to raise a kid by herself. So one thing to do is to try to hook the male to get him to play a paternal active role. What about the shape of human females? All right, from a zoological point of view, the fat distribution in women is a sexually selective trait that advertises the ability to raise fat and brainy babies. And incidentally, there's no relation between the size of a breast and the milk production. The milk glands are independent almost of the fat that surrounds them. And as I said before, a big fat breast, it has absolutely no influence on the amount of milk that's produced, nor is the fat from the breast burned up to make milk. It's there to just give it that look. You could almost say that breasts are an evolutionary trick, a lie for snagging men. It signals a woman's ability to feed her children and to have sexy, brainy offspring. Another hypothesis is that when humans became upright, the parts that advertised estrus became hidden as it would be in other monkeys. And so the buttocks the breasts are another sort of sexual signal that emulate the buttocks in an upright posture. All right, now let's just consider the evolution of this thing briefly. Why do we suddenly need brainy monkeys or brainy hominids? In the transition from life in the trees to that on the ground, a premium was placed on the role of fat, on the role of intelligence, the role of being able to figure out this new environment and cope with it. That required better brains required better fat. So we have three key changes here from this change from an arboreal life to a terrestrial life. And there's this creature, the Ardipithecus ramidus, from about 4.5 million years ago, that has the joints in the wrist and in the ankles and in the back that made it very agile still in the trees, but at the same time it permitted it also to walk on the ground. So this Ardipithecus ramidus is sort of in the transitional phase. We don't know what sort of a fat distribution it had, but in the evolution, if it became, in the evolution to the human lineage, it would have required a more upright posture and the fat distribution would have changed. So our hypothesis is that the human traits of shapely, sexy, adipose, tissue-rich mothers were needed to develop brainy babies could not have evolved until after the hominids, the ancestral command, had abandoned the arboreal lifestyle that set constraints on fatness. You're never going to get a very intelligent, smart monkey in the trees as you do humans on the ground. So this image that we have here of a shapely female living in the trees, that is paradoxical. It's not a design that would work. And with that, I close my lecture, and I thank you for listening. And I want to thank some of my supporters. It's the National Institute of Fundamental Studies, University of Pennsylvania, particularly the veterinary faculty, the Department of Archaeology, the Central Cultural Fund, certainly the Department of Wildlife Conservation, the Smithsonian Institution, where I'm an associate and have many years of support, Center of Field Research in the USA, and last but not least, my staff who worked with me at Polonrua under the non-profit company that we call the Association for the Conservation of Primate Diversity. And you can look us up on the internet at www.primates.lk. Not primates.com, you'll end up somewhere else, but primates.lk. And thank you, and I'm open to questions if you have any.
What determines rank? What determines rank? Is it genetic? And can a low-ranking female produce a high-ranking female or son?
What determines rank in macaque society is the question. It is not genetically inherited in either males or females. Rank is socially inherited from one generation to another by way of the mother. A high-ranking male or high-ranking female, by her behavior, protects her young daughters, and they learn eventually to exploit other low-ranking females, and that is how rank is passed from one generation to another. And yes, there can be upsets to the female hierarchy. I mean, some female families have been the highest ranking for more than 40 years. Others, there have been changes. The low-ranking females, they form a coalition and they challenge the so-called queens. And there's a lot of fighting that goes on, and the loser in these hierarchical battles, they are then excommunicated, or they're from the group. And once they're ostracized to leave the group, then their prospects of survival are very slim, because there are so many other groups in the area, they have no living space of their own. Amongst the males, you had the question was also, can a son of a low-ranking female achieve high rank? He can, but it's less likely to do so than the son of a high-ranking female, simply because the son of a high-ranking female has more access to food, he grows better, and he has the social confidence to sort of impose his will upon others. Of course, there are battles amongst males. Once they leave the group, they're no longer under maternal protection. And sometimes, a high-ranking male dies, and the second ranking or the third ranking male then achieves alpha rank. So the males probably have a greater chance, the sons of low-ranking females have a greater chance of achieving a high rank once they leave their mother's group with their mother's influence and the group's influence than do the daughters.
I read somewhere that the Barbary apes in Europe, that the mothers eat the placenta after giving birth. Is that common among monkeys?
The statement was that in Barbary apes of northern Africa, the mothers are known to eat the placenta after birth, and that is a common pattern in all mammals, including the primates. I wouldn't be surprised if our ancestral humans fried up in a placenta and shared it amongst themselves. It would make sense.
One more question, if I may. You're talking about inbreeding. I understand all the hamsters in the laboratories all over the world, they are descended from 6 hamsters that were discovered in Syria, and they never found any wild hamsters after that. How is it that inbreeding didn't take the effectivity of inbreeding didn't take place in hamsters?
Well, this question of inbreeding is an interesting one. I mean, normally inbreeding causes defective, deleterious results, but sometimes, particularly as we just mentioned under laboratory conditions, they are purposely inbred. That means 90% of them die from some sort of genetic defect. But there's a very intense selection going on in the laboratory. Those who actually survive inbreeding are then just stocked for successive generations that then survive. So whatever sort of deleterious genes sort of emerged in the inbreeding event is selected out by humans. That's why we have lines of inbred hamsters that seem to be seemingly healthy.
Too much adipose fat has a deleterious effect on humans.
Probably yes. Yeah, I mean, I don't want to say anything controversial in this audience, but looking at ancestral humans, that's safer because nobody knows what they look like anyway, so I postulate. Ancestral humans didn't have more than 5% body fat total. And they had to move. I mean, hunter-gatherers walked 15 kilometers a day or more in order to find their food. Now, if you're going to be living off berries and fruits and whatever else you find in the forest and grubs and the occasional piece of meat, you're not going to have much opportunity to grow much fat. And in addition to that, fat would interfere with locomotion. So as it does in fat monkeys. Fat monkeys, they get bulbous in the axilla. They can't even move their arms properly. These fellows can't climb. And I would think the same would occur. I mean, looking around looking around human society today, how many of these females do you think, or males or females really, how many adults, how many obese people do you think could walk a kilometer? How many could even walk 50 meters? I mean, they get into a car to go to the grocery shop, to go to the car. Even they buy houses that don't have steps because they can't handle the steps. I mean, yeah, obesity is a serious problem. Now, does it have an effect on brain development? Well, I would think that there's a cutoff point at which and I would think, 5% body fat is probably sufficient to ensure that you can produce brainy babies. And anything more than that, you're not going to get a brainier baby, probably not, no.
Heard about a sort of white morph, purple-faced leaf monkey in the south popping up. Is that true? And if
yes, they are.
Why?
They are. They are a genetic variation. They're not leucistic. They're actually what do you call them? They have patches of white and black fur. Just one of these things that happens every now and then in the wild. You also get albino. This is not albinism. It's different from albinism. You also get albino macaques showing up. Probably, maybe, purple-faced languors, especially live in small groups, they don't move very far. There may be an element of inbreeding going on there. Who knows? It has to be investigated, but it is true. Such monkeys exist. Yeah.
Is there a reason for the red pigmentation on some monkeys and some not having it? Is there a difference between the sexes or developmental stage?
The question was about the red faces in macaque females. In general, in primates, in macaque species, the females tend to develop red faces and the males do not. So it's one thing, again, that immediately identifies male and female. The degree of redness does not really increase with estrus or with reproductive readiness. It does get more red with heat, temperature. And the redness is really caused by fine blood vessels under the skin. And the degree of redness runs in families. So we, as human observers, can tell, that's the red family, that's the pale-faced can, that's the blotched-faced family. So the degree of redness is also inherited, this time genetically, from the mother to her daughters.
There's no functional purpose.
Other than identifying, assisting in giving a monkey an individuality, I don't see much to it here because it doesn't really advertise estrus as what you might expect. It gets a little deeper redness with age, but monkeys male monkeys don't really care much about the age of a female. They don't care about her fat either. Male monkeys are attracted to female monkeys by their smell and by the taste of the vaginal fluids that are used to advertise estrus. And vision is, unlike in humans or in baboons, which are ground living, visual signs are not really very useful for advertising estrus, because if you're living up in a tree, you can't be seen very far. You're going to be seen 5 or 10 meters, pointless. If you're living in the savannah like baboons do, then there's an advantage to having a big bulbous rear end to advertise your estrus in baboons.
Are monkeys carriers of rabies?
All mammals are potential carriers of babies. However, having said that, I've yet to find a monkey that has rabies. Of course, the conventional wisdom or approach of the medical community here and elsewhere is that if somebody's been bitten by a monkey, they give anti-rabies shots. But I mean, that's overkill precaution. I mean, I've never actually been bitten by a monkey, but I've trapped monkeys and I've cut myself on their canine teeth. Hopefully I don't have rabies. And yeah, normally when people are bitten by monkeys, it's not because the monkey is a rabbit, it's because the human has been stupid. He's been behaving in an inappropriate way in relation to the monkey. And that happens so often by tour guides. Tour guides show foreign tourists around. They try to get monkeys to come close to the jeep so the tourist can take a nice photograph and give the tour guide a big tip. That sort of behavior is really not very good for monkeys, tourists, or anything. And what happens is that monkeys get so used to people and they get aggressive. Now, let me tell you something about monkey society. Monkeys don't give food to one another, they don't share food. A mother, when she finds a nice fruit, she doesn't say, put double on them, there's a nice fruit, you eat this. No. She may hold it in her hand and the son may take it from her hand, but not the same as actually giving it. She's more tolerant in allowing her children to eat nearby, but she doesn't actually ever give a food to them. But what happens always in monkey society is that a high-ranking male or high-ranking individual will steal food, rob food from a low-ranking one. So there's this exploitation. A high-ranking monkey steals from a low-ranking. So if you as a human being go and give a banana to a monkey, you'll say, oh, this human being is subordinate to me. He's just proven that he's subordinate. And then he will treat you as his subordinate. Even if he's so big, you think you're a big, silly human being, and you're subordinate. And then if you give the first banana, okay, but then you don't want to give the second banana, but you have it in your pocket, that monkey's going to go for that second banana because it's his right to do so, because he's dominant to you, and you've proven that he's dominant to you because you've given him a banana already. So people don't understand that. So that's what gets people into lots of trouble, and that's when they get bitten. And also people, they tease monkeys by giving food and withholding it. And that monkey gets mad and you may jump at you and bite you. You deserve it. That's a question.
Did your research involve fertility and menopause?
Does it include which?
Research include fertility?
Not fertility in the physiological sense, but fertility only in the sense of number of babies born in relation to other behavioral and ecological factors.
Menopause?
After menopause, after menopause, they have babies, yes.
They have?
Yeah, they have. Yeah, interesting. In most vertebrate species, when the female is no longer capable of having babies, they die. In monkeys, these old grannies, they can live for another 5-6 years without having babies. So the question is, for us as sociobiologists, is, well, why are these old ladies still living? They should be dead. Maybe they have a positive function for the society. Do children with grandmothers in the group, do they survive better than children that don't have grandmothers? Does the grandmother have some sort of positive effect on the survivorship of the grandchildren? That is the question. And the answer to that is yes, of course. Grannies have a positive effect on the survivorship of the grandchildren. That is why in macaques, these old females still live past menopause. And that differs in males. Males, once they're old, they just die off. I mean, they just, or they hang around and they beg for tolerance and they're very subordinate. They're power actually. Except, even at 30 years old, they can still reproduce. Get that, huh? You can still sire offspring is what I mean. I have one old male who was in the temple, who was in the Monkey Kingdom film. who's one is a grandpa, the fellow with the hunchback. We've done some detailed behavioral studies on him. And he doesn't do, he feeds, every female that comes by, he investigates, for genital reason, whether she's ready for mating. He tries and he tries and he tries. He never succeeds, mind you, but he certainly doesn't stop, not from lack of trying. So this sort of drive for sex in these males is very strong. It lasts to the end of their life. Maybe not unlike humans, huh? Thank you. It's always a pleasure having an audience to listen to me.